Every home has a microwave oven. In this documentary, we will see how, using sophisticated electronic systems and specialized software, this equipment can be used in a particular way to recreate an iPhone using basic chemical elements that can easily be obtained from a scientific laboratory. It is one of the new, darker sides of the microwave oven. You've probably seen videos on the internet showing the physical changes a bar of soap undergoes when placed in a microwave oven. But we should be careful and not just believe everything we find on the web. So we're going to do that experiment again in a specialized laboratory so we can confirm it with a committee of scientists. Firstly, we'll need a microwave oven. We unplug it carefully. We make sure we keep the technical documentation safe. Then we connect the oven to the mains in the physics laboratory. We take a simple bar of soap. We remove the bar of soap from its packaging and place it in the microwave. We set the oven on full power for a period of 10 seconds. Then we press the power button. Now we open the oven door. We find that the electromagnetic waves emitted by the oven have deconstructed the material that makes up the soap and thus altered its shape. Now we repeat the experiment for a period of 20 seconds, still at full power. The soap has indeed lost its original shape. It is undeniable that our microwave oven is capable of changing the physical structure of our soap in a totally haphazard and random manner. The web videos showing this experiment can therefore be confirmed by the committee of physicists from the Physofilm laboratory. We can then ask whether it is possible to orientate and arrange the oven's electromagnetic waves so as to go the other way and give an object a definite shape. This operation requires intervention on the microwave oven's electromagnetic wave generator. We carefully pull out the oven's cover to access the wave generator's electronic control board. The oven's wiring diagram allows us to locate the generator and its controller. Then, using a very precise operating mode, we work on the electronic board that makes the oven's wave generator function. We unplug the electrical connectors and pull the control board out of the oven. We gather all the technical equipment we need to alter the structure of the control board electrically. We locate on the circuit diagram and then on the board the electronic components behind the disorganized and random sequencing of the wave generator. We unsolder these components to neutralize them. Now we connect a bundle of multi-stranded electric wire to the board so we can command and take control of the oven's generator using a remote computer system. The wire conductors are soldered onto the circuit board one after the other, according to a specific arrangement. The multi-strand electrical cable connections are now complete. We can clearly see the board and the soldered bundle of wires. Now it's necessary to connect the other end of the multi-stranded cable to an appropriate adapter to communicate with the oven's wave generator. As in the previous step, it's necessary to respect the connector's wiring plan. When this operation is completed, we can replace the control board and reconnect the electrical connectors. Now we replace the oven's cover, being careful not to pinch the bundle of cable strands. We can clearly see the connector soldered to the bundle of wires coming out of the oven. Then we use an extension cable to connect the microwave oven to the remote sequencing system. We connect one end of this extension to the microwave connector and the other end to a digital power card fed by a symmetrical 5-channel pulse transformer to provide the energy necessary for the electronic sequencing chain. The heart of the system is a sequential processor for interfacing between the digital power card and the computer, communicating with a USB port that we use to connect the synchronous serial cable. The electronic chain for coherent sequencing of the oven's electromagnetic waves is now operational and must be controlled by specialized software. All that remains is for us to include in the program the mathematical sequence for the specific molecular restructuring process. Let's study a physical object with simple shape and composition, such as an eraser. This everyday object is extremely interesting to study because it has a simple rectangular shape and is made up of a small number of chemical elements. Now we will use a structural holographic scanner using a pulsed laser beam to model and translate the physical aspect of this eraser into a mathematical equation that is usable by the electronic sequencing chain we have previously prepared. The holographic scanner consists of a pulsed high-energy laser beam capable of transcribing the physical form of any object placed in the light beam into a mathematical sequence. This laser is then connected to a processing board, which is itself connected to a digital acquisition card, allowing a computer and its associated analysis software to perform holographic scanning of the shape of the object. We connect the regulated symmetrical DC power supply and power up the pulsed laser beam, carefully modulating its output to prevent any risk of fire. The structural holographic shape scanner is now fully operational. Then we generate the last lines of code, completing the computer program that allows software management of our holographic scanner. We remove the eraser's cardboard case in order to perform the structural analysis. We position the eraser facing the scanner's laser. The laser is not yet being pulsed, so the ray remains stable. Now we launch the acquisition process. The eraser is analyzed by the pulsed laser beam. Its structure and its dimensions are modeled and communicated to the computer by the acquisition card. A complex mathematical equation models the eraser's physical properties in full. The transmitted data is displayed on the computer screen. We transfer the equation for the mathematical sequence to a USB memory stick. This mathematical sequence, which reflects the physical appearance of the eraser, can now be used by the electronic coherent sequencing chain for the electromagnetic waves that we looked at previously. It's time to find out if the oven associated with the electronic coherent sequencing chain of electromagnetic waves can resequence the shape of our eraser from the mathematical sequence we obtained previously. To do that, we will change the physical characteristics of the eraser, making one part smaller and making sure we keep the parts we have removed. We will power up the electronic coherent sequencing chain for the electromagnetic waves that we prepared previously. We insert the last sequential connectors and check the operation of the assembly. The indicator lights show that it is working. The backlit LED display indicates that the system is ready for the restructuring phase. We insert the USB memory stick containing the mathematical equation modeling the physical characteristics of the eraser obtained by the holographic scanner into the computer's USB port. Finally, we place the eraser and all its residues in the microwave oven. We generate the last lines of codes, finalizing the computer program to allow the restructuring process. Then we launch the electronic processing chain. The oven switches on automatically, and the duration of the cycle is determined by the software. The control unit display shows the smooth transfer of data to the oven's wave generator. The digital data is transferred in uninterrupted streams. The DC power unit supplies peaks of power according to the progress of the eraser restructuring process. If all goes as planned, the whole mechanism will allow the eraser to regain its original shape. The ordering of the material is finished. Now we open the oven door. The results are spectacular. The eraser has regained its original shape. It is like new. We find and successfully confirm that the oven's waves make it possible to restructure matter when they are produced in a coherent and ordered mathematical sequence specific to the properties of the object. Our experiment is a great success. Let us push our investigation further. We found that the eraser was reconstructed in its original form from a resequencing of its unstructured elements. We can then ask whether it is now possible to make the same eraser from the individual chemical elements that compose it. We have seen that the pulsed laser beam structural holographic form scanner has allowed us to model its physical structure. Let us now make use of an atomic analyzer based on magnetic resonance imaging, MRI, to unlock the secrets of the matter and find out the precise chemical composition of our eraser. It's fairly simple to build this type of device. We'll need some coils of enameled copper wire. We prepare a coil of copper wire that we wind on a ferrite magnetic core. This coil will allow us to produce a sufficiently strong magnetic field to penetrate the secrets of the matter. The finished coil is protected with a plastic protective film. We solder connectors for connections between the coil and the external electric circuit. To get the strong magnetic field necessary for our experiment, it's essential to cool the copper coil with liquid helium to achieve a state of superconductivity, allowing the circulation of a very large current. We will use insulated gloves to protect ourselves from the intense cold generated by the liquid helium. We carefully pick up a bottle of liquid helium. We insert a flexible tube into the valve of the helium cylinder. The coil is placed in a glass container. We open the valve to release the pressurized liquid helium. The helium gradually covers the coil. It is now fully immersed in liquid helium. We move the current generator to supply the coil and make the electrical connection using a cable of sufficient diameter to withstand extreme currents. The object to be analyzed will then be subjected to the strong magnetic field generated by the coil. It is essential to create a diamagnetic structure that is not sensitive to the magnetic field in order to deposit the object to be analyzed on it without being in contact directly or indirectly with the liquid helium. You can easily find this kind of structure in kit form in all furniture stores. It's made of compressed wood fiberboard, which is flame retardant, with low formaldehyde emissions in line with EU standards. Assembly is very easy, which means that any family could make an atomic analyzer, MRI. The support is placed on the coil, immersed in the liquid helium. 7 electronic sensors, sensitive to atomic radiation, placed in the axis of the magnetic field, are used to transmit the information to software specially dedicated to the atomic analysis of matter. The experiment can now begin. We take our eraser again, taking care to remove the plastic wrap and the cardboard case. We place it in the center and in the axis of the magnetic field created by the superconducting coil. We program the computer sequence, instructing the generator to deliver a current of 5,000 amps. We find that our 5,000 amp current flowing in the superconducting coil is too large and has the unexpected result of making the eraser levitate. The result is surprising. Computing a new sequence tells us to reduce the current to just 3,000 amps, and the eraser regains its stability. The analysis is complete. It is now possible to discover the chemical composition of the eraser. The peaks indicate the presence of the fundamental chemical elements that make up the eraser's matter. We clearly discover the presence of chloride atoms, potassium sulfate, and dihydrogen monoxide. The amounts and proportions of the elements are known with exceptional atomic precision. Only a chemistry lab can give us access to all these basic chemical components of the eraser. These items are available in secure vials and containers. We carefully collect the boxes containing each of the 3 compounds and use an extremely precise pair of scales. Using the classification produced by the atomic analyzer, We prepare a mineral atomic powder consisting of the 3 basic chemical components of the eraser. We measure the mass of each of the 3 basic chemical elements precisely using the pair of scales. We carry out the same operation for the other 2 substances. Then we mix the 3 precisely measured chemical compounds together. Note that the total mass of the inorganic powder is strictly identical to the eraser we want to reconstruct. All we have to do now is to put the atomic mineral powder we have obtained in the microwave oven and give the oven's electromagnetic wave generator a coherent and orderly sequence corresponding to the physical structure of our eraser. We insert the USB memory stick with the mathematical equation modeling the physical structure of the eraser. We start the sequencing software. The digital data is transferred in uninterrupted streams. The regulated power supply delivers power peaks. The oven starts up on its own, and the cycle time is determined automatically by the software. The restructuring process proceeds normally. The oven buzzes. The ordering of the matter is complete. Now we open the oven door. The results are spectacular. The atomic mineral powder has been completely redesigned to form an eraser completely identical to the original. This eraser looks like new. It is an exact copy of our model, which has now been cloned. The experiment is a great success. We find and confirm that the oven's waves make it possible to restructure matter when they are produced in a coherent and orderly sequence. There is no real value in reconstructing simple, mundane objects, especially something as cheap as an eraser. It is financially more interesting to clone a technologically complex and particularly costly object such as an iPhone. We carefully unpack it. To perform the experiment in the best conditions, the device must be new so that it is not contaminated by foreign substances. We subject the iPhone to the pulsed laser beam holographic structural shape scanner. Using the computer software for digital acquisition by a mathematical equation, we model physical structure of the device. We install the program we have stored on the digital magnetic support. We launch the pulsed laser beam acquisition process. The structure of the device is modeled digitally. Then we use the MRI atomic analyzer to learn the exact composition of the unit. A current of 3000 amps through the superconductive coil seems reasonable. The analysis shows that the chemical composition of the iPhone is far more complex than that of the eraser. While the latter contained only 3 chemical elements, the iPhone contains 69. We find carbon, hydrogen, calcium, barium, cobalt, lithium, strontium, germanium, vanadium, nickel, copper, iron, zinc, aluminium, magnesium, manganese, lead, sodium, gold, silver, neodymium, and also metals from the rare earth group such as scandium and dysprosium. Again, only a chemistry lab will allow us to have access to all these basic chemical elements. We carefully collect the boxes containing the basic compounds constituting the iPhone. We lay them out on the experimental bench. Once again, we use the extreme precision scales and develop the atomic mineral powder composed of the chemical elements making up the iPhone. We take each item from the list of chemical compounds resulting from the atomic analysis and measure it out with extreme precision to a tolerance of 1/1000th of a gram. We carefully combine all the basic compounds and blend them together. As indicated by the precision scales, the total mass of the atomic mineral powder obtained is exactly the weight of the iPhone. As with the eraser, all we have to do now is place the atomic mineral powder obtained in the microwave oven and run the oven's electromagnetic wave generator in a coherent and orderly sequence corresponding to the physical structure of the iPhone, stored in memory after the holographic structural shape analysis performed previously. We check the correct connections of the restructuring device again. The sequencer is ready to start the restructuring process. We insert the USB memory stick with the mathematical equation modeling the physical structure of the iPhone. We start the sequencing software. The oven starts up on its own, and the cycle time is determined automatically by the software. The digital data is transferred in uninterrupted streams. The process is underway. It is now irreversible. The wait is unbearable. The experiment was a success with the eraser. Will it work again with the iPhone? The results are outstanding. The iPhone was perfectly reconstructed from the atomic mineral powder developed in our laboratory. The experiment is an incredible success. The atomic reconstruction is extraordinary. The clone device is identical to the original object in all respects. There is no way to tell them apart. If we look at the memory contents of the clone device, it is exactly the same as for the original device. The atomic precision of the reconstitution even allows us to duplicate the content of the device's memory atom by atom. The experiment is a success, a great step forward for humanity. Our planet is facing a growing global demand for food resources. The whole of mankind must find new sources of sustenance to support themselves without threatening the delicate balance of our Earth. We now know that with basic chemical elements associated with huge microwave ovens and atomic mass restructuring units, we can provide an inexhaustible source of clean, renewable, and high-quality power.